Plasma torus. A torus is a three-dimensional form, similar to that of a donut. Plasma is one of the four fundamental states of matter in the universe: solid, liquid, gas, and plasma. Plasma is created by either heating a gas or subjecting a gas to a strong electromagnetic field. Interestingly, it does not occur naturally on the Earth's surface. Plasma most commonly occurs in two forms: partially ionized and fully ionized. Partially ionized plasma exists on Earth in the form of lightning and neon signs. Fully ionized plasma, on the other hand, occurs at the centers of stars and in the energy surrounding them. Plasma tori are most commonly produced by the interaction of a satellite's atmosphere with the magnetic field of a planet. A revealing example of a plasma torus is the one surrounding Jupiter. On Io, one of Jupiter's moons, volcanoes release large amounts of charged gas into the atmosphere in the form of sulfur dioxide. This sulfur dioxide is then ionized by solar ultraviolet radiation, producing positively charged ions of sulfur and oxygen, as well as negatively charged electrons. These particles follow the moon's angular velocity around Jupiter. Because they have a charge and are in motion, they create a current. This current, in turn, creates a magnetic field which forms the plasma into a torus. This is but a fraction of Jupiter's magnetosphere, which protects its atmosphere from coming into contact with the solar wind, a stream of charged particles that escapes from the upper atmosphere of the Sun due to their high energy. This high energy is a result of the intense heat of the corona that can be up to 450 times hotter than the surface of the Sun. The solar wind causes the sun-facing side of Jupiter's magnetic field to compress, while the far side lengthens, creating a long tail. This tail can fit the Sun and its corona within it, with space to spare. If viewed from Earth, the magnetosphere would appear 5 times larger than the Moon, although it is 1,700 times farther away. Another example of a plasma torus is nuclear fusion. Nuclear fusion is the process of creating energy by fusing together two atoms into one with less mass, releasing kinetic energy in the process. This energy can be collected by humans. It is not only eco-friendly, but reliable. It releases no CO2 gas and produces no radioactive waste. If properly executed, 1 glass of water could create as much energy as a barrel of gasoline. When enough heat is applied, the hydrogen atoms in the water are able to fuse into one helium molecule, releasing energy. This is the same process the Sun uses to produce its energy. However, the Earth is minuscule in comparison. Thus, a different technique is necessary. In order to overcome Coulomb's law and fuse two atoms together, the temperature of the plasma would need to be 1 billion degrees Kelvin. However, if we look at the bell curve of all the particles' temperatures, we see that while the average temperature is too low for fusion to take place, there will still be a small number of particles that will move fast enough to allow the nuclear strong force to take over and fuse the atoms together. There is a greater than 0% chance of achieving fusion, so the average temperature need only be 100 to 150 million degrees Kelvin for nuclear fusion to occur. Yet this is still an incredibly high temperature. In comparison, a diamond will liquefy at 4,000 degrees Kelvin, a factor of 37,500 less. To hold the plasma in place, we can use a magnetic field in a vacuum. To do this, we start by imagining an infinitely long solenoid to direct a straight magnetic field through a tube. In order to make this tube finite, we can twist the solenoid into a loop, resulting in a torus structure. By looking at the bird's eye view of the structure, however, we see that because the magnetic field was constant throughout the straight solenoid, and because of the change in radius on the new torus, the magnetic field will be stronger the closer you get to the center. When we apply the right-hand rule, we see that the particles within the chamber will actually move upwards. To fix this, we induct a current through the plasma itself to create an additional toroid magnetic field, resulting in a twisted combination of the two fields with an even force throughout. This is called a tokamak, and was first invented in the 1950s by Soviet physicist Igor Tamm. Eventually, the machine inducts too much current in the plasma, making it unstable. This means that a tokamak cannot run continuously. In order to make the machine continuous, the current running through the plasma must be removed, and instead the torus and the plasma within it are twisted to balance out the magnetic field. This machine was developed by physicist Lyman Spitzer of Princeton University in the mid-1950s. It was called a stellarator, referring to the possibility of harnessing the power of the sun, a stellar object. In modern times, the energy required to carry out this process is greater than the energy it produces, but as technology improves, so does its efficiency. So we can imagine a point in the future when the energy created outweighs the energy needed. This will be a great replacement for gasoline, coal, and other sources of unclean energy, and result in a source of green, efficient energy. Thank you.